Hello dear students. In this lecture we will see final value theorem. In last lecture we have seen initial value theorem. Similarly we will see final value theorem. If we understand initial value theorem, you will easily understand final value theorem. All that we have discussed in initial value theorem, the same things are here with some minor modification. Now let us see what is the theorem. If the function ft and its derivative f dash t are Laplace transformable, then what is the final value theorem? Final value theorem is limit t tends to infinity ft is equal to limit s tends to infinity s into fs. This is the theorem. Now we prove it. Let us start. So Laplace transform of f dash t is equal to s into Laplace transform of ft minus f0, which is equal to sfs minus f0. By taking limit s tends to 0 on both sides, we get limit s tends to 0, Laplace transform of f dash t is equal to limit s tends to 0, sfs minus f0. So if we know that Laplace transform of f dash t is equal to 0 to infinity f dash t into e raised to minus st dt, we get the entire equation as limit s tends to 0 integration 0 to infinity ft e raised to minus st dt is equal to limit s fs minus f0. Therefore 0 to infinity integration 0 to infinity f dash t dt is equal to limit s tends to 0 s fs minus f0. Now as limit is s tends to 0, e raised to minus st will become 1. So we get integration 0 to infinity f dash t dt is equal to limit s tends to 0 s fs minus f0. Now by first theorem of calculus, we know that 0 to infinity f dash t dt is equal to limit t tends to infinity ft minus limit t tends to 0 ft is equal to limit s to 0 s fs minus f0. Here f0 is not a function of s, so it get cancelled from both the sides. As we are looking at the final value theorem, f0 is not a function of s. So if we cancel f0 from both sides, we get limit t tends to infinity ft is equal to limit s tends to 0 s into fs, which is the required final value theorem. So in this way, we have seen the final value theorem of Laplace transform. Thank you for listening.